I have no idea when this stream is going to start. Oh, dear. Hey! Hello, coders. Hello, coders. Welcome to episode 97 of the How to Code Well podcast. This, of course, is live as it is every week. So if you've got any questions or suggestions or comments, then please do let me know throughout the show, and I might get to them and answer them. Today we're going to be talking about hardware, in particular whether or not developers should work on crummy, old, poor hardware which is pretty run down. And the reason the school of thought here is that if you're forced to work on a machine that is really rubbish, like doesn't have great memory, doesn't have great hard drive space, doesn't have great CPU or GPU, or just doesn't have a GPU, then you are essentially forcing that developer to write efficient code. The argument is that if a developer works on the best machine ever, and to be fair, hardware is relatively cheap compared to, well, you can get a lot of bang for your buck. Let's say a developer who works on a really mint machine will always be tempted to write poorly written code because they can get away with it because their machine can take it. We're going to take a look at both viewpoints today, and we're going to just sort of discuss the topic as a whole. I also want to move not just on web development, but also on software development in general, and talk about hardware that isn't necessarily crappy hardware, but hardware in other industries as well. So it's a bit of a broad-reaching episode, I suppose. So let's talk about the reasons why you should use crappy hardware to write software. So the reasons why is obviously testing, right? Because you're writing code on hardware that is perhaps used by the general public, or used by the minority of your users, and therefore if you can get your code to run as efficiently with the minority, then the majority will obviously work wonders, right? Because you've targeted the lowest entry point into your system in terms of hardware spec. You then have, after testing, you've also got performance. So again, making sure that your system can run on the same as good on high-end machines as it is on low-end machines. So making sure that the performance is okay across the board. You've also got compatibility. In the web development space, you have compatibility with browsers. So you may notice that some of your users might be using or running a very old version of a particular browser, and that particular browser doesn't support some of the new fancy features in CSS or JavaScript or whatnot, and you are catering for that group. Again, we're following on the abilities. You also have accessibility as well. So you are ensuring that your system is as accessible as possible to your whole audience. There could also be other hardware needs as well, and this is where we kind of veer off of the web development world and we move into other things. So, for instance, there could be the fact that you might be working on a system, and that system requires other hardware to integrate, and so emulation of that system and that integration might be troublesome, and therefore having an actual physical thing to test with is would make your life probably slightly easier. Ultimately, though, this all comes back down to quicker feedback loops. So, for instance, if you're working on a nice super fandangled machine that has a lot of hardware to throw at it, you would have to be running through a series of emulations in order to replicate the lower graded hardware that you want to try and scale down. And because it's not a true one-to-one experience, you are having to rely upon the emulation to send back the feedback that you require. So actually having a physical box, which is a truer representation of the hardware that you might be writing software for, may give you a quicker feedback loop. It also means that you have you literally have one-to-one experience. If you were to buy in the poorly equipped hardware to write software against, you have that true one-to-one experience with that. So you can actually put yourself in the user's shoes, and you get an understanding of not only how the software runs and works, but also perhaps the frustrations that a user may have because of the system is so low spec. And of course, the ultimate plus side to all of this is that you cannot hide bad code, because if you're working on a very tight sort of series of constraints, your hardware must only have this amount of RAM, this amount of CPU, this amount of storage space, then you've got a very small sort of constraint to work in, and therefore you would be writing a really efficient code first rather than the other way around. So just getting code to, because we often we write lots of code and we don't necessarily think about performance. We don't think about the end user. We just get something to work, and then after that we go through a series of iterations to clean it up, to make it a little bit more efficient, to monitor it and stuff. But when you're working on lower spec hardware, you don't have that room to maneuver. So there are some plus points to this. Let's talk about reasons not to, though, because this is important. So reasons to have the best machine ever to do your development on is one is security, right? So you are always developing against them as a system that is as up to date as possible, in the sense of, let's say, for instance, even if we go back to web development with browsers, if you have to run against a browser and that browser was a very old browser, then perhaps that browser requires an old operating system that isn't very secure anymore. So security is a byproduct of the thing that you are using, obviously. So the other plus point is that you can try a lot of things out. You can throw a lot of things at the wall because you've got enough hardware to back your code up. Even if it's the most inefficient code ever, you can just throw things at it and just try things out. You have that ability to maneuver and play with different things. And also you can test different scenarios quickly. So if you were to have a series of virtual machines, you can create various different scenarios that tailor to various different sort of circumstances. So for instance, going back to the web development, you could have various different operating systems installed on your own host machine through a series of virtual machines or parallels or what have you. And you could replicate your users, your customers' environments, and you could scale down your virtual hardware to match those things. So you could do that. And you could create a series of test suites. If we were talking about performance, that run against those various different types of virtual machines. Yeah, and then I guess you've got the ability to scale upwards, right? So you're not always forced to work on the hardware that your users are working on. And I've mentioned this a few times already about you having better hardware than your end users. That's just the case. As software developers, we tend to care more about the tech. And it doesn't necessarily mean caring about tech in terms of a laptop or a desktop, but it's also, a techie would, in my opinion, would normally have a really good television set, TV, or I don't know, any kind of hardware where they can actually have a look at the specifications and do a little bit of in-depth reading. They, because of their nature of writing software that goes against hardware, they would be more interested in perhaps the hardware side in terms of just looking at specifications and comparing things. They would be able to decipher the jargon on the general hardware specifications. And as developers, we tend to buy laptops, buy desktops, buy monitors, buy TVs, buy all sorts of camera equipment, all sorts of things where we have gone through and researched, and we know the difference between, I don't know, one model of CPU versus another model of CPU, because that's what we care about, because that's what we do, that's the world that we live in. Whereas perhaps other people that are in other industries, they just want to get something to run. So they'll be less interested in, how much memory something has versus, they'll be more interested in the cost rather than interested in the actual, what they can get for the cost, if that makes sense. So what I'm saying is by default, we tend to buy better spec machines because we know what we're buying, because that's the world we live in. But it isn't necessarily the right thing for certain situations. So for instance, as I mentioned, it's very easy to get into this sort of mindset that everyone's machine is as good as yours, and therefore you can write code and just refresh the page, and you just assume that your page refresh is going to run as fast or as good or look as good and look as nice as everyone else's, because everyone else's should be running on your hardware. There's a sort of a mindset there. It takes a bit of effort in order to create a series of virtual machines to mimic the various states of your potential customers or clients or what have you. Whereas the flip side to this is if you actually had some really old hardware, then that decision is taken away from you, and you must work within that space. Now, I'll give you my sort of reasons here is reasonings as to what I think. I think developers should work on the best tools that they can possibly buy. I think a developer, when they purchase a laptop or a desktop, they should be trying to spec it out to the hills. And I think that the team should, or the person in charge of purchasing the hardware and the equipment, they should be seeing hardware specifications like gateways of efficiency. So in order to be more efficient as a developer, I think a developer needs to have the tools that the developer needs. And also, there's a lot of things that we do as devs that your general users won't do. So, for instance, we will write scripts that loop over thousands, tens of thousands, hundreds of thousands, millions of records. We store assets of the whole website. We store huge, big databases, and we run jobs against it, and all sorts of things. So by definition, our development machine must be better than the average users, in my opinion. And then you would go through, as I said, a series of virtual machines to scale down and try and mimic that kind of environment. But I have played with both things. So, for instance, right now, I mean, I'm looking at some really great equipment in terms of what I use. But I've also worked on things like microcontrollers, so where you're actually working against the hardware. And this is where you're perhaps not using a VDU, so like a visual display unit. This is actually using like controlling lights, or you're controlling something else like a temperature gauge, or some sort of, I don't know, wireless thing or something else, or IoT, where you actually need to play around with the physical hardware, and you're having to write code against that physical hardware. So in that kind of space, yes, you definitely need to work against the hardware. And I certainly recommend that if anybody's doing any work that writes against hardware, or there is maybe you're creating a system in which you are installing, so perhaps one of these vanilla boxes you can get a vanilla like Linux box, and install it in your client's office, maybe, that does something, right? That's quite a common use case. If you're doing that, then make sure that you not only have some testing hardware to play with for your developers that actually is the same hardware that you're going to supply to your customers, but you also have that as a software emulation as well, so you can spin that up. But I certainly think that there needs to be like another stage beyond just software emulation. There should also be hardware testing as well. But again, this is going outside of the the world of web development. So, for instance, as an example, I created some software once where I was interfacing with another piece of hardware. So I had this software, this system, sorry, and it did a load of polling. So it was polling for things for input, and then when another piece of hardware was input, it would pick that up. So that kind of interaction you cannot really emulate. You need to actually have, because it requires a physical thing to happen. You can't really emulate that. So there are some caveats to this, of course. So in my opinion, most devs keep older hardware though around, but have one super awesome machine that they can use for development. So I do think that developers, they tend to keep old hardware around, which is useful. I mean, for instance, I have a series of old phones just lying about, which is good for testing for mobile sites and systems, and that's a sort of a different thing to web development, in the sense of with web development you literally just look at a display unit, a monitor. With a mobile phone there is so much more interaction, and those interactions change depending on the model, depending on the brand, depending on the version, the version of that phone. So for instance, I can't remember what version it was, but iPhone brought in the Force Touch thing, and you have different things for Android that you do have with different variants of different variants of iPhone. They're obviously very different, but there are things on the phone that you really can't emulate very well, like for instance the camera. And the rotation, that kind of thing, finger placement. That's, as I mentioned, with this sort of accessibility. It feels, when you're emulating a phone, it feels very awkward. You're having to use a mouse to replicate the finger point. So that can be quite troublesome. And this is why mobile development is, in my opinion, can be quite awkward, because you build this piece of software on a device that isn't your device that you're going to use. So let's just go back on that for a minute. So, like for instance, we build websites every day, and we build websites on laptops and desktops. We also look at and use websites on laptops and desktops. You can't say the same thing for phones. You can't say I've built a mobile app on a mobile. It's different, totally different. So it's a different experience. You as a developer, you have to change your mindset to, okay, so I've just created this lovely piece of code, and I can see some graphical interface that looks like the phone, and I can see it being used, but it's a totally different experience to, let's bundle up this piece of software and put it onto the mobile phone and see how that works and see how that interacts. Yes, my emulator could be this fast. It could be quite fast or it could be quite slow. But until I actually get it on my phone, and until I can actually get that interacting with a phone that has, I don't know, hardly any space or is bloated up with other apps, then it's a different experience. It's a very different kind of experience. So, I mean, a plus for having all of this, having good hardware is, of course, smooth development, having a means of creating a nice sort of working flow, if you will, nice snappy development. And you can create lots of different iterations of hardware configurations, which is really handy, really nice, and obviously, as I mentioned, virtual machines are a good way to do this. So, I personally, I don't think it's a good idea to limit your developers to crappy old hardware. However, I do see the benefits of having a testing lab that has the hardware in which those your general users, your customers, your clients will be using. But I think for the development team, they should be on the most powerful pieces of equipment that they can possibly get their hands on. Now, there is obviously a flip side to this, because we've only been looking at this from sort of like top down, but what about bottom up? No, hang on. We've only been looking at it from bottom up, so crappy hardware up. What about the other way around? So what about if you were to write software for a supercomputer? What if the system that you are putting your code onto is far better than the system that you're writing for, just because you can't afford to have a supercomputer? I mean, I've never come into that sort of experience before, obviously, but it'll be very interesting to hear from anybody who has the ability to write code that goes to a machine that is far superior than the machine that the code was written on. That's a sort of a flip to that, and how they manage that. Odd, isn't it? Very weird way of thinking. So I guess another piece to this is something that I want to talk about in regards to companies, in terms of, like, if you're a one-man band like me, then you really should keep old hardware around, I reckon, because you'll never know. And there's most drawers in this. Well, every drawer in this office, plus most drawers in the house, there is a man cave. You open it up and it's a man drawer, and it's full of cables and all sorts of old chargers and bits and knickknacks and stuff like that, old tech. But I do think that it's very handy to have these devices around just in case you want to test with them. But if you are a company and you have a team of developers, then as I mentioned, I think it's better to get those devs on really good hardware. Don't limit those devs, because the thing is, when you limit the devs, you end up limiting your productivity, and that's not a good thing. Instead of limiting the devs, create a test environment, like a test lab that you use. Hey, thank you for joining, Martin95. Thank you, 958. Thank you. Sorry, I couldn't see over the microphone arm. If you want to buy some crypto now, by the end of the year, you'll probably be able to afford very good hardware. Yes. Yeah, I didn't jump on that the Bitcoin bandwagon. I was tempted, but I didn't really do anything with it. I do know some people who've done it and done quite well off of it, but it didn't. I don't know. I was more interested with how it worked rather than sort of why it worked, if that makes sense. So you're saying code to the lowest common denominator? Testing on a standard laptop can show results of slow page loading speeds. Yes, definitely. Definitely. But I do think that if you're able to emulate that, that is far better, I think. Emulate that on a really powerful machine. I think that's far better for the developer than forcing that developer to code on a very slow machine, because coding and testing are two very different things, in my opinion. Hey, Bernard, thank you for joining. Awesome. Yeah, it's an interesting topic. It is an interesting topic. I mean, it makes sense to just go, oh well, I mean, we're software developers. Software developers get paid a lot of money, right? So we have the resource in order to buy the latest and greatest. If we're lucky enough and we are paid enough, then yeah, we can do that. And if you have your own business like I do, then it's important to make sure that your gear is as up to date and as good as it possibly can be. But then there is an interesting question though, or argument or discussion. What we're having today is, is the best thing to use? Or should there be the rubbish stuff that you can use to mimic those sort of situations? In my opinion, as I mentioned, you need to have the best stuff for productivity, but then you should also have the ability to emulate those rubbish situations. Now, there are obviously a lot of things that developers, web developers in particular, can use some services, Browser Stack being one, in order to spin up virtual machines in the cloud in order to emulate those sort of rubbish browser versions. The problem with all of this, though, is that you end up going through the emulation, which means that you don't always get a true representation of that old hardware, because you are going through a virtual machine on the cloud. So there's a lot of hoops to jump through. So yeah, interesting. So before I go today, I want to mention a interesting book that I've read recently, and this is Getting Started in Tech: A Guide to Building a Tech Career. This is a great beginner's guide. It's also not just a beginner's guide, it's also a guide if you want to switch different industries. We mentioned today about web development, but also we kind of played around with the idea of different industries as well, and also especially testing. So, QA testing or UA, all those kind of testing sort of situation, testing hardware, testing software, that kind of stuff. So if you want to jump from one industry to another industry, this book is really good for letting you get a grasp on the ins and outs, the pros and cons of these various different industries. It's like I said, it's not just for newbies, but for those who are looking to transition to other parts of the tech industry. It explains how to actually go about picking a particular field. I wish I read this book when I started web development, or even started getting into the IT, the computing space, because this lays it out in a very nice to digest way. It also talks about how to scale your career, the various different entry paths as well, the pros and cons of each of those fields, as I've mentioned, and the tips on how to land your first job. Now, unfortunately, I'm probably gonna butcher the name of the author. It's Amarachi, or Amy Cruz for short, on Twitter. So I've got a link in the description below if anybody's interested. It's a very interesting book. And even though I've been in the industry for many, many years, I actually came away from this with some extra knowledge as to the other particular fields. And I was able to sort of, when I got to the pros and cons section, I was like, yes, that's why I chose web development. That makes sense. Yay. So yeah, go check it out. It's Getting Started in Tech: A Guide to a guide to building a tech career. It's the first link in the description below. Right, before I leave, I've just got one more thing to do, and that is to talk about some announcements. There is a couple of announcements that I want to make around How to Code Well. Things are slightly going to change. So at the moment, what happens is that on a Thursday, I obviously do this. This is the podcast. This also goes out the following week on the actual podcast player. So you can listen to this episode on iTunes, on Spotify, on wherever you get your podcast from. You can listen to How to Code Well. So this happens on the Thursday. On the Sunday, I do a live stream on Twitch. That's twitch.tv/How to Code Well. And we are building the howtocodewell.net e-learning platform. And we've been doing that every Sunday. And that's really good. That starts at 14:30 GMT or BST, whatever time zone we're now in. I don't know. And that usually goes up to about 5:30, maybe 4:30, 5:30. Really depends on how much progress we're making. And there is another one which is Tuesday mornings at 7 a.m. 7 a.m. to 8:30. That's twitch.tv/How to Code Well as well. But there's going to be a change. And the change is this. I am dropping the Tuesday stream. I'm dropping the Tuesday morning stream, and instead I am going to be streaming code on YouTube. So I'm going to be building the howtocodewell.net website on YouTube as well as the Sunday stream on Twitch. Now, I haven't really decided yet on which day I'm going to do it on. It's going to be, though, in the evening. So it's either going to be Monday night or Tuesday night. That's probably the two that because I think Wednesday's too close to Thursday, plus I've got other things that I want to do. But yeah, it's either going to be the Monday night or the Tuesday night. I'm still trying to work out timings and when's best. But that's going to be happening on YouTube, and we will be building the How to Code Well stuff. Another announcement is usually what happens is every month I do a code challenge, and that is reviewed live on Twitch. What I'm going to do is I'm going to put those challenges on hold until I get the howtocodewell.net website actually up and live in the state I want it to be in. Because right now we are working on some business critical features at the moment, like Stripe, for instance, and the subscription service and all of that stuff. I want to focus my time and energy on getting that out rather than having to come up with challenges every month. That actually takes a lot of time to do. So we're going to put those on hold. And I do think that once that website goes live, and I'll talk about this in more detail when we're closer to the point, but I do think that the content that I actually produce will be slightly different, because we'll be moving away from, once the site's live, I'll be moving into more of a headspace of maintenance rather than feature development, and also marketing. And so my time would be spent building content, courses and all that. I mean, we haven't built a course on How to Code Well this year, which makes me feel a little uncomfortable. And I've said that I won't be building another course until that site is up and finished, or up and ready for a new course to come along. So once that site comes along, I'm going to need to spend some time to build that content, those courses. And what I'm thinking of doing is planning those courses on Twitch and maybe coming up with some code on the YouTube. I don't know. I don't really know how that's going to play out, but it's going to be slightly different. So anyway, thank you ever so much for joining today. I really do appreciate all your feedback and your questions and everything. It's been great. It's an interesting topic. Should devs use crappy hardware for testing or other general cases? Please do check out that book from Amarachi. Amy Cruz, check her out. It's I'll put a link to the book in the show notes. Getting Started in Tech, a guide to building a tech career. Thank you ever so much for watching. Happy coding, everybody, and I'll see you again soon. Cheers. Bye-bye.